Πολύ ωραία. Λοιπόν, να ξεκινήσουμε. Να σας καλωσορίσω όλους στην τρίτη από τις 4 προσυκλημένες ομιλίες που οργανώνουμε στο εργαστήριο Data Science σε θέματα επιστήμης δεδομένων, σε συνεργασία και με το Μεταπτυχιακό Κυβερνοασφάλεια και Επιστήμη Δεδομένων. Σήμερα είναι μεγάλη χαρά μας που έχουμε ως καλεσμένο μας ομιλητή τον κύριο Περικλή Ανδρίτσο. Ο Περικλής είναι καθηγητής στο Πανεπιστήμιο του Τορόντο. Πήρε το πτυχίο του ηλεκτρολόγου μηχανικού στο Πολυτεχνείο εδώ στην Αθήνα, μεταπτυχιακό και διδακτορικό στο Τορόντο. Έχει πολύ σημαντικό ερευνητικό έργο στις περιοχές του data management, data analytics κλπ. Αλλά και μεγάλη δραστηριότητα στις startup εταιρείες, όπως γράφουμε και στο βιογραφικό που έχουμε ανεβάσει στο Teams. Να μην πάρω άλλο από το χρόνο, γιατί είχαμε και αυτές τις μικρές τεχνικές καθυστερήσεις. Περικλή, ευχαριστούμε πάρα πολύ που είσαι εδώ μαζί μας και ο λόγος σε σένα.
Εγώ ευχαριστώ. Καλή χρονιά σε όλους, καλή αρχή σε ό,τι και αν κάνετε. Μεγάλη μου τιμή να παρουσιάσω τη δουλειά μου στο group σας. Θα πρέπει να πω ότι είναι η πρώτη ομιλία που δίνω σε ελληνικό πανεπιστήμιο μετά από πάρα πολλά χρόνια, οπότε έχετε και την πρωτιά, έχω την πρωτιά μάλλον εγώ στο να το κάνω αυτό. Βρίσκομαι πάρα πολλά χρόνια στο εξωτερικό, από το 1998. Δεν ξέρω αν μπορώ να κάνω τα πάντα στα ελληνικά. Είναι κάποιες ορολογίες που όσο και αν προσπάθησα δεν μου βγαίνουν. Οπότε σε αυτό το κομμάτι θέλω να ζητήσω συγγνώμη. Έχει να κάνει με το ότι κάποιες από τις ορολογίες απλά δεν τις έχω. Όπως είπε και ο Γιάννης, είμαι στο Τορόντο. Δεν προχωράει. Είμαι στο Τορόντο από το 1998, οπότε και πήρα το πτυχίο μου από το Μετσόβιο Πολυτεχνείο και ήμουνα μέλος του group του τίμου του ΣΕΛΗ, που νομίζω ότι τον ακούσατε πριν τα Χριστούγεννα, αν δεν κάνω λάθος, κοιτάζοντας λιγάκι τα βίντεο που έχουν αναρτηθεί. Συνέχισα με το Master και το PhD στο Πανεπιστήμιο του Τορόντο και στο group των βάσεων δεδομένων. Κομμάτι της δουλειάς μου, που το συνεχίζω λιγάκι ακόμα και τώρα, έχει να κάνει με clustering of categorical data και κατασκεύασα τότε έναν αλγόριθμο που λέγεται Limbo. Βασίζεται στη θεωρία πληροφορίας και χρησιμοποίησα data mining και data science τεχνικές για να βρω structure, δομή σε μεγάλα δεδομένα. Δίδαξα στην Ιταλία και στην Ελβετία, οπότε γνωρίζω λιγάκι το ευρωπαϊκό κομμάτι της δουλειάς και της έρευνας και έχω υπάρξει co-founder 2 startup, της Θώρα και της Οντέα. Η Θώρα έχει να κάνει με τη συνέχιση της δουλειάς μου στο διδακτορικό. Η Οντέα έχει να κάνει με πράγματα που θα σας παρουσιάσω σήμερα. Αυτή τη στιγμή βρίσκομαι στο Faculty of Information του Πανεπιστημίου του Τορόντο σαν καθηγητής και θα σας παρουσιάσω δουλειά που έχει ξεκινήσει όχι πολλά χρόνια πριν. Ήταν όταν βρισκόμουν στην Ελβετία και με πλησίασε ένας διδακτορικός φοιτητής να κάνει τη δουλειά μαζί μου, οπότε και ξεκινήσαμε κάτι εντελώς καινούργιο, το οποίο συνδυάζει κάποια πράγματα και η παρουσίαση σήμερα θα είναι ένα ας πούμε ποτπουρί αυτών των διαφόρων contribution που έχουμε κάνει. Θα το γυρίσω λιγάκι στα αγγλικά. Γιάννη, ελπίζω να είναι εντάξει. Θα προσπαθήσω να το συνδέσω και με ελληνικά, αλλά δεν είμαι σίγουρος ότι θα τα καταφέρω, όπως είπα, πολύ καλά.
Δεν υπάρχει πρόβλημα, Περικλή, όπως βγαίνει πιο άνετα.
Ναι. Ευχαριστώ. Θα μιλήσουμε για Customer Journey Maps, για Customer Journey Discovery, Ήθελα να κάνω ένα demo σε ένα εργαλείο που έχουμε ένα βιντεάκι το οποίο χρησιμοποιούμε τώρα, το οποίο έχει ανέβει στο YouTube. Θα αφήσω όλα τα link και τα slides μετά στο Γιάννη, οπότε όποιος ενδιαφέρεται μπορεί να το δει. Δυστυχώς το εργαλείο έχει κατέβει, ο σερβερ έχει κατέβει λόγω των διάφορων προβλημάτων που υπήρχαν με την Java πριν τα Χριστούγεννα και έγινε ένας αρκετά μεγάλος πανικός παντού. Θα μιλήσουμε για κάτι που το ονομάζουμε Truncated Trace Classifier και Path Prediction. Θα εξηγήσω ένα προς ένα τι είναι όλα αυτά. Όπως είπα, είναι ένα pot-pourri. Σε κάποια σημεία δεν θα μπω σε τεράστιες λεπτομέρειες. Υπάρχουν papers, υπάρχουν demos και θα καταλήξω με ένα-δύο κομμάτια της δουλειάς που έχουμε κάνει τώρα. Κάποια από αυτή τη δουλειά την τελειώσαμε πριν τα Χριστούγεννα και θα σας εξηγήσω τι είναι. Λοιπόν, θα μιλήσω για services, τα οποία έχουν αρχίσει να γίνονται αρκετά complex τα τελευταία 20 με 30 χρόνια. Ο λόγος για τον οποίο τα services έχουν γίνει τόσο περίπλοκα είναι γιατί έχουμε καινούργιες συσκευές, έχουμε tablets, έχουμε smartphones, έχουμε έξυπνα ρολόγια, καινούργιες τεχνολογίες με τις οποίες οποιοσδήποτε χρήστης μπορεί να κάνει interactions, όπως τα chatbots. Έχουμε καινούργια κανάλια στα οποία διοχετεύεται πληροφορία. Φυσικά τα social media είναι πάνω απ' όλα το μεγαλύτερο παράδειγμα. Όλα αυτά κάνουν τα interactions των χρηστών όχι μόνο περίπλοκα, αλλά και μοναδικά, unique. Κάποιοι ερευνητές πριν από μερικά χρόνια, το 2016, βγήκαν και είπαν ότι όλα αυτά στο conceptual επίπεδο είναι καλά, αλλά δεν έχουμε κάνει καμία δουλειά πάνω στο data-driven κομμάτι. Δηλαδή, services υπάρχουν, δημιουργούνται, γίνονται design, αλλά εμείς δεν έχουμε καλό understanding των λεγόμενων customer journeys. What is a customer journey? Θα σας πω σε λίγο. Αυτή η δουλειά είναι η τομή, το intersection μεταξύ δύο περιοχών. Η μία περιοχή λέγεται process mining, η δεύτερη περιοχή λέγεται customer journey analytics. Αν ξεκινήσουμε από το process mining, τι είναι το process mining? Στο ένα κομμάτι έχουμε data science, το οποίο θεωρείται process agnostic. Data science is said to be process agnostic in the sense that it cannot play with process models, so it is data driven. Process science, on the other hand, is a discipline such as the business process management that tends to disregard the evidence, so the data that we have at hand. So this work is a missing link. It's a bridge that provides tools that put process mining, so basically process models and data together. Η δουλειά αυτή ξεκίνησε το 2016, περίπου εκεί, όταν ο Γκαέλ Μπερνάρ, τον έχω στο title slide, ήρθε και μου είπε ότι έχω access σε δεδομένα από πωλήσεις μεγάλων dealer αυτοκινήτων στη Γερμανία. Τα δεδομένα αυτά ήταν interactions που υπήρχαν μεταξύ των πελατών και των ανθρώπων που δούλευαν στα dealerships. Τα δεδομένα αυτά δεν τα πήραμε, αλλά ξεκινήσαμε να δουλεύουμε πάνω σε δεδομένα τα οποία είναι όπως αυτό που έχω εδώ στο slide, για παράδειγμα, και έχει να κάνει με car rental. So, what is an event log? Before talking about the event log, I need to say that the most granular information that we will consider is an event. And an event is a particular action that a customer or that happened at a specific time. So we have timestamps and we have the title of the event. A collection of events performed by the same user, by the same process, is called a trace. And a collection of traces is called an event log. You can also think about the event logs, the logs that the web servers are collecting when we interact with specific services online, such as e-commerce and so on and so forth. Now, this is at the conceptual level. There is also a language. There is also actually not a language, but an XML standard that stores event logs, and this is called the XCS standard. So process mining is using XCS, XML-like standard to store and processes and process processes. Now, process mining is a framework. It has been put forward at the University of Eindhoven in Holland by a famous professor called Wil van der Aalst. He put forward the whole community. It is composed of many components, and at the top and at the bottom of this framework, we have the event logs, which is either current data or historical data. Current data will become historical data, and the models. So if you want, at the top we have data, at the bottom we have models. So the models are either de jure models. So de jure models is how we think the model should be executed. It means what have we designed before we execute anything. The de facto models are process models that are being discovered using data. Okay, so process mining can be defined as all the activities that go within, and we can take a top-down approach to go from the historical or the current data and discover models, and these models will be the de facto. Using data, we discover de facto models, or we can go the other way around, bottom up, or that takes the process model and make sure it is executed as we believe it should be executed, right? So it's the same way that you design a database. You design a database, you have the schema of the database, and then you want your data to populate this database and adhere to all the constraints and all the design constraints that you have put forward, primary keys, foreign keys, and so on and so forth. We don't have all this stuff here, but I'm just making the analogy. There is a lot more to discuss here. I am not going to touch on all these things. You can explore, you can predict, you can recommend, and so on and so forth. So this is the framework used in the area of process mining, okay? Now, customer journeys, on the other hand, is basically a sequence of touch points. A customer journey is a sequence of interactions between a customer and the service provider. So the term customer journey has gained a lot of popularity after 2013, 2014, because the stakeholders within companies, they want to understand how the different services are being used. So a customer journey mapping is a tool that helps us to manage and understand, if you want, how customers behave, feel, and what are the motivations and their attitudes when they consume a service. Again, it has links to user experience design. It's being used there, but in our work, we are following a totally data-driven approach. You can see that the main components here, as I will show you, is basically a two-dimensional place, like a graph, if you want, where the x-axis has to do with the sequence of the activities. It is basically time, what happens over time, and what happens, we call it a touch point. So here we have touch points, which are different actions that have to do with car rental, returning a car, picking up a car, and so on and so forth. There are, in this picture, 3 journeys, which means 3 different ways of renting a car, right? So renting a car from partner, upgrading to VIP, picking up the car, returning the car, and the other 2 are quite self-explanatory. So in this particular small case, visualizing and looking at the customer journeys is not very difficult, right? what happens though when these journeys increase, when we have hundreds, thousands, or millions of journeys? So how can we go about analyzing them? And this was the gist of our motivation, right? Customer journeys are increasing. We need to do something about it. Now, a customer journey map has the abbreviation of CJM. So you will hear me saying CJM sometimes more than a customer journey map, just because I'm used to that. So there are two different kinds of CJMs, if I may say. The first is the design of the expected customer journeys. This is an actual picture by Deloitte, Netherlands. So these are consultants, these are employees that use big boards, and they sit there all day and they try to figure out how the different goals of a system can be achieved by following different journeys. They write stuff on post-it notes and they put them one another to represent journeys. So these are actually the expected journeys, right? So we design the journeys at this point, and then we go back to the customer and say, this is what you should do to achieve A, this is what you should do to achieve B, and so on and so forth when your customers consume your service. The second, the next slide is an IBM tool that shows actually journeys as they are in the system. What do I mean by that? These are the actual journeys. These are journeys that are being depicted here by pulling data of the interactions of customers with particular service, right? So these are the actual journeys. These are the data-driven journeys. So this is what basically existed up until a few years ago. And in this work, we took the the data-driven approach one step further. We like to say customer journeys on steroids, right? So we added some data science onto it. And the research questions that in brief are being presented here is, how can customer journey maps be discovered, explored, and enhanced from the event logs? And how can the touch points of a customer journey be predicted? So we're looking at discovery, we're looking at predictions, and I'm going to show you two contributions from each of these questions. So I'm going to talk about genetic customer journey discovery. I would like to show you the demo of the CJM Explorer, but as I said, it's down. Let's see if I can share a few bits of the video. And then I'm going to talk about our truncated trace classifier. I will explain what this is, and the path prediction. So let's see. Now, as I said, this is brand new work. So this more or less started gaining some traction in 2019. We have been, basically Gael has done most of the work. I supervised and guided him, but we have been the first ones that we looked at what the value of existing ideas is in process mining and how these ideas can be incorporated into customer journeys, right? So data science approaches from process mining, looking at their similarities, going into customer journeys. So we also proposed an XCS format so that we don't only have process mining event logs, but we also have customer journey event logs and so on and so forth. That's how we started. And just a quick overview of, and this is kind of brief and abstract. There are many more things to say here. Some things we know, some things we don't know yet. So on the left-hand side, I have terminology from process mining. On the right-hand side, I have terminology from customer journey mapping. So a trace is a journey, an event is a touch point, so that the Euro process models are related to the expected CJMs, and the de facto are the actual CJMs, right? So the same they convey similar ideas, and we have used this as our starting point. So I will now provide an overview of our contributions using some simple dotted chart, where a square represents different types of touch points. Different types have to do with different colors. So in the discovery and the first stream of research, we take those 5 journeys and we cluster them horizontally, right? So you have cluster 1 and cluster 2. If you remember from my PhD days, I am hooked up with clustering. So I've been using clustering wherever I find it suitable. I give it to my students. They apply it into different areas of research. So the first component is horizontal clustering, the clustering that we all know, and these contributions are using this clustering. So the genetic customer journey discovery and the CJM Explorer. Actually, since I talked about co-founding 2 companies, the second company, Odea, is based on the CJM Explorer. The ideas behind CJM Explorer have been evolved into a startup company. Then we have a vertical clustering. So maybe let's say that we observe that blue and light blue, these 2 different types of actions are appearing together many times. To make the dotted chart less crowded, so we propose an algorithm that is heavily based on process mining to create something that we call the CJM abstractor. So it helps the user, it helps the person who's looking at this visual to make cleaner and faster decisions. And the last component has to do with how the different events are going to finish. So this is related to something that is also called in the community as NBA, next best action, not basketball. I always like to call it NBA. So we have a couple of papers there that we're looking at how the traces are going to likely end. The 4th contribution that I have here actually won the Best Paper Award in a database conference, in a European database conference, ADBIS, a couple of years ago. And we are going to look at it. So let's look at the discovery, customer journey discovery. I have also references to some of our papers, but Gail has collected them into a nice website. I will give it to Yanis afterwards. So this is a typical data set that is being used in customer journey mapping. This is called the Chicago data set. The data set has to do with activities that people, citizens of Chicago, perform every day. So work, school, go to church, go shopping, working from home, and so on and so forth. So this is a publicly available data set, and it is very interesting because together with the touch points that the different citizens perform, it also gives us demographic information. So apart from the dynamic information in the journeys, it also uses static information. So how old is the citizen? What is the salary of the citizen? What is the race of the citizen? And so the gender and so on and so forth. It has about 30,000 journeys. There are some statistics at the top. And the issue is that that's fine, but when we plot it, we get this spaghetti CJM, as we call it. So you understand that there's nothing to be discovered here as it is visually. And we used several techniques to be able to discern clusters, let's say, and representative journeys. So our algorithm summarizes the sequence of activities but also considers contextual information. If you remember, I mentioned contextual information, and we believe that income, age, level of education is going to give us better results and better understanding of what's happening underneath, right? So the high income, we can tag different journeys as high income, car owners, young people, and so on and so forth. We are going to look at what are the best representative journeys here, what are the journeys with the highest discriminating power among all these 30,000 in this particular case, or any other data set. This is our guinea pig data set, and that's what we use. So we tried a genetic approach. The genetic approach is motivated by the process mining community. It's being used in process mining in some works in order to discover business process models. So what is the genetic approach like? So first, we generate a random population of solutions. Then we evaluate the quality of these solutions, and we remove the ones with the lowest quality, exactly like Darwin's theory, survival of the fittest. So we have actually some fitness measures. Then we apply some transformation to the best solutions. And we apply these steps many, many times and recursively until we converge to the best, if you want, solution. Yes, it sounds a little bit expensive, but this is one of the first algorithms we tried, and it worked extremely well, outperforming some existing algorithms. So how does it concretely work? There's a whole paper, but let me try in a few couple of slides to show you. So we randomly generate hundreds of CJEMs to form an initial population. And first, we use a particular distance that is based on edit distance. It's called the Levenstein distance. It's a normalized edit distance, if you want, considering the length of these activities. And we assign the actual journeys based on the distance in the event logs to the closest representative journeys in the customer journey maps. So we evaluate the quality of these metrics, and we use 3 quality criteria. A lot of details are described in the paper, but the first one is a fitness that measures the distance between the actual and the representative journey. The second metric, so we do a generation, we keep the best ones, we assign the actual journeys to these best representatives. Okay, we measure the fitness. The second metric, it is guiding us toward a desired number of journeys. We don't want our results to have thousands of journeys, so we restrict the number of journeys. And finally, because as I mentioned, we use contextual distance, contextual information, we use cosine similarity in order to find distance between the context, the age, the income, and so on and so forth. So this is going to improve the results. As you see, this is something that gives a little bit of an interesting twist into our approach that others do not. So generation 1 is giving us the 0.5 as the best. Generation 2 is giving us again some others that are pretty good. Now, the transformations that we apply here, similar to any genetic algorithm, is we add a touch point, we remove a touch point, we add a journey, we remove a journey, and we have crossover. So we have journeys that intersect with each other until the different generations end. We assess the quality, and at the end, we end up with the number of representative journeys that represent, if you want, as best as possible, the full data set. So millions of journeys, or in this case that I'm going to show you, 30,000 of journeys went down into these 3 best representative journeys. Now, these experiments stops after we see that there's no improvement in the quality. And in this particular case, of our data set, it took up to 30 generations to achieve good results. So in our evaluation, we use 40 synthetic CJMs, and actually we produced some of the 40 synthetic CJMs, and we alter them, we change them, and our goal was to use the Jacquard distance to see how close we were to the actual journeys that we would find. So we used measures from a tool that is used in sequence mining, and that is called the TraMiner. The TraMiner is using different metrics such as the sequence likelihood, the centrality, the frequency, and so on and so forth. In the top of the graph, you see generic 1, which is our generic algorithm without contextual information. So TraMiner doesn't use contextual information, so we wanted to be fair. We did it this way. And then we have contextual information, which is improving the result. I forgot to say that the closer we are to the left, the better. So you can see that even though there is a little bit of variance in our results, we still outperform, even in the worst case, the existing state of the art. So our approach outperforms TraMiner to retrieve the ground truth, okay? So this is domain agnostic, so you can use it in any domain. We don't do anything with semantics. Of course, the genetic approach is a little bit expensive, and on top of it, the Levenshtein distance is a bit expensive. We are working toward that. We have some solutions, and I will discuss them toward the end in future work. So part of the discovery is also our tool called the CJM Explorer. So the CJM Explorer is an interactive tool that helps us to figure out what's happening inside large CJMs. The web interface is actually, it exists here in this URL. The URL is down. I will give you the YouTube video that explains the whole tool, but the gist is that we ingest a data set, we feed a data set into the system, we build a dendrogram. You can see a dendrogram behind here. You can see a little bit of how the tool looks like. On the left, you have the best representatives. Here we choose the number 3. On the right, you have a whole tree of the dendrogram that we built using our approach. So the users can click on the left and they can navigate into the different levels of this tree from the root, which are the 3 journeys that represent the whole data set, but you can hierarchically go all the way down to the leaves and see the individual journeys. Let me try one more time if I can share this, my Chrome browser. If I cannot, I will send you the link. Okay. All right. I think I have something. Can you see my browser?
Ναι, μια χαρά.
Το βλέπετε, έτσι. Λοιπόν, I will be brief. So, ο Γκάελ περιγράφει τι γίνεται.
Of journeys. We can put them all on the same map because, as you can see here, it is quickly overloaded. And this is the case even with only few journeys. This is the challenge we solve by proposing CGMX. CGMX solves this problem with hierarchical clustering, and I will now explain the mechanism. Let's say that we have the following sets of journeys, where each letter represents an activity, and say that we would like to have only 2 journeys maximum appearing on the same customer journey map. The first step is to measure the distance between these.
Εδώ ο Γκάελ περιγράφει πώς κάνουμε το clustering, το οποίο θα το προσπεράσω. Είναι ένα κλασικό hierarchical clustering, στο οποίο χρησιμοποιούμε και frequent item set mining. Αλλά θα περάσω λίγο στο demo για να μην σπαταλήσω πολύ χρόνο. Ακούγεται ο ήχος, ελπίζω. Έχω βάλει τον ήχο να ακούγεται.
How it works with a concrete example. The Chicago Activity Survey is an extensive dataset that describes almost 30,000 real journeys. Real in the sense that these journeys were really experienced by people. For this dataset, a journey represents what activity a person is doing from the moment he wakes up until he goes to sleep. For instance, being at home, going to work, doing shopping, and going back home is an example of a typical journey. This dataset is interesting because we have not only many patterns of activities, we encourage you to upload your own dataset. Application. The first one is the customer journey map view, which purpose is to easily compare the patterns of activities of journeys that are on the same hierarchical level. The second one is the tree. Its goal is to display the hierarchical structure of the clusters, which gives some indication on where we currently are. The third one is a box per cluster, which provide a convenient means to display some statistics about the journey, such as the salient characteristic. I will come back to these salient characteristics later. Let's focus on the customer journey map and say that I'm not interested in people attending class or people that go shopping. I will therefore click on the more generic pattern, all of the home activities. You can see that it is more general because the line is heavier. This is an information that you can also see here. The journey contains more than 2,000 distinct journeys, while the others have only 161 and 63 distinct journeys. Note that two people might have the exact same pattern of activities during a journey. It will be counted as one journey in distinct journeys, but as two in total number of journeys. Hence the difference between distinct and total numbers of journeys. To enter in this cluster, I can click on the button Enter the layer. As you can see, all three views are updated synchronously. I can come back and click on the customer journey map view, or come back and click on the three, and we will always arrive in the same cluster.
Για να προχωρήσω λίγο στην παρουσίαση, αλλά καταλαβαίνετε ότι μπορείς να κάνεις navigate σε διάφορα επίπεδα και το επιπλέον το πλεονέκτημα που υπάρχει εδώ είναι ότι μπορείς να βάλεις και στόχους. So everything is stored in a data warehouse. So by inputting goals, so give me everybody who is of a particular age, works in a particular environment, and so on and so forth, is actually of my interest. So go and filter out this part on the tree. So we found some discrepancies, and actually one of the issues of the exercises that I give in my class to my students is that they take this tool and they try to find something interesting in their data. I did it last year for the first time. It was pretty interesting because they were astonished by the fact that cool stuff came up from their project. So I will elevate my speed a bit. So the truncated trace classifier was motivated by a particular challenge that exists in the community, in the business process management community. So what is a truncated trace? So it's best to show it with the picture. So we have three traces. We can see the different events of the traces. So because a lot of information from historical data is extracted at particular dates, when we have a particular extraction, we may explore journeys that have not finished yet. So they are truncated. So if I make an extraction here on the 25th of May, the second trace is going to be truncated. I won't have the last part. So in this work, we basically participated in the challenge. We actually came in the top 10. And the idea was to convert the problem into a classification problem, right? So a truncated trace classifier, or a TTC, is a classifier that predicts if a trace is complete or truncated. And there are three advantages. So the first one is that we make the process models more precise. So no good data, we don't have good models, right? Bad data, bad quality of results. So we were able to improve the discovery of process models. We repair the process discovery event logs. So the organizers of the competition, they intentionally removed events from the end of the traces that they gave. So we were able to recover what would happen, or basically if the event logs would be truncated or not. And of course, improve the operational efficiency. So if you have like business rules such that if you have a ticketing system, this ticket is supposed to be closed, but it is not closed, then I should be doing something. So I can predict whether the ticket is about to be closed or should be closed, right? So the idea is based on prefixes. So we take the traces of the input and we split them into all their prefixes. So if we are not at the end, the trace is still truncated. If we arrive at the end, we give the label false, which means it is not truncated. So we have the full one. So we have different versions of classifications algorithms based on the last activity, based on different features that exist in the traces. These features are the number of activities in the prefix, so how long or how short they are, the seconds, so the time since the first event in the trace, the time since the previous event in the trace. Then we have a frequency based, how many times different activities exist together with the base features and everything together. And here we use a standard decision tree, ensemble of decision trees, XGBoost, to perform the classification. We also use two versions of an LSTM, which is a neural network, one based on softmax and the other one based on the sigmoid. So this is the correlation. And quickly, I need to tell you that basically the approach for FB, like the frequency based with the last activity, is performing the best by giving on the average the best correlation. We tried it on all the 13 real data sets that they gave us. The importance is that here is real. We did not know what the activities meant. Everything was like A, B, D, F, and so on and so forth. So we were able to rank in the top 10 using these different classification algorithms on the different data sets. And you can see low numbers in the bottom one, but some of the data sets were completely messed up, okay? So there were from activities, sets of activities that did not make any sense. So we improved the precision of discover process models here, and we improve the next event predictions. Now, the last part before we finish is the path prediction. So that is a paper that we published in ADBIS and got the best paper award in 2019. So what are the most likely next touch points? So this is the tool, this is our work that demonstrates pretty well the connection between, if you want, CJMs and process mining. One of the reasons that it got this award. It can be seen as a natural step after the truncated trace classifier, but we are also basing it on a business on process model or a process model. So I will briefly describe it. The procedure has different steps, and it is starting by discovering a process model. So I am giving the algorithm as an input, a set of traces. Here are some set of traces, A, B, D, E, F. So these are all different activities, right? That form the different traces. Now, if I apply a process mining algorithm, the output is going to be a business model. So, or a process model, better. I am sorry, a process model. This process model here is a possible output, and in this algorithm, we use it. We use the so-called process tree. Process trees are trees of the different types of activities and connectors that you can have between your activities. At the bottom, you have your activities, and you have a hierarchical view, and it goes from left to right as well as to how it is being read. So first step is build a business, a process model, sorry, a process tree. Then we take again the traces, excuse me, and you replay them, as we say. So we throw them into the process tree, and we report how this process tree and how many times it is being used, okay? So you see here an AND connector, and yet here you have an XOR, and here you have an AND. So A and B are going to be done together, and then you have an XOR between this part of the tree, the AND4, and the XOR. So you see that it is being read hierarchically, top down, left to right. So if I am taking the first trace and I replay it on the system, the first time I am going through AND2, I am going through AND2 a second time for the D, and I am going a third time for the B. So over here, these are counts of the number of times that we use the different nodes in the process tree. Now, this particular representation, the matrix, it needs a couple of times to be understood. It's called LAFM. It's loop-aware footprint matrix. So, because it takes into account also loops. Something that differentiates us from other prediction algorithms is that we take into account in a seamless way the loops that may exist in the different traces, right? And the same thing is happening for all the traces. So basically, we built this matrix, and out of this matrix, we built a BPMN, a business process model derived from the process tree. If now I have a prefix, if I want to know what is going to happen, for example, after D, so I can very easily traverse the BPMN, and it will output what is happening in my system. So D is going to have, there is an AND, so I have a D and the XOR. If the XOR goes to AND4, I am going to look at how many times I am using the AND4 in the different traces. So I am going to go to A, I am going to go to B, I am going to go to E, and so on and so forth. I know I'm going a little bit fast, but basically the predicted path, which is A, B, E, F, E, which is the biggest lesson, is not just like any random sequence of events. It's not like I'm going to do, yeah, at some point I'm going to do A, I'm going to do E, I'm going to do F, and so on and so forth. But the process tree I had before, together with the LAFM, they help me build this business process model that help me make predictions according to business rules, according to a business process model, not just random. So there is a business model that guides my prediction. Okay, so this is the biggest thing of this algorithm. It accounts for loops. It has this representation of all the different types of nodes of the process tree, and based on the business process model, I make good predictions. And we have an approach that doesn't consider the whole data set, the whole set of traces. So the idea here is that you may have 1 million traces. So if you have 1 million traces and you create only one BPMN, there may be mistakes, there may be errors. And in our view, what we tried is that what if we first cluster the traces? So we don't use the 1 million traces, but we use 10 clusters of traces. And we go and we do the actual prediction within these clusters. This means that I am going to do a different LiFM representation for each cluster, a different prediction. And this improved our results heavily. So for large event logs, we use a soft clustering that improves. So you see that LiFM is above LSTM. LSTM is one of the state-of-the-art in neural networks for sequence events, for event sequences, I'm sorry. So we're always, because this is a similarity, we're always above. We have outperformed or at least be equal. So it works with complex logs and it's pretty accurate, okay? So to conclude, I have taken the process mining, I have added to it the correspondence with the CJMs, so something that we discussed in the introduction, how the actual reflect to the de facto, how the expected reflect to the de jure. We looked at the discovery, exploration, we enhanced, we didn't talk about the abstractor, and then the prediction. Now, the work in progress is that we are working on the partitioning of unlabeled customer journeys. So when I'm showing you customer journeys, I assume that somebody has given you the different journeys that the user has performed, right? User did this at that time, did this at that time, so you can build a customer journey. Now, imagine that you have a health app, an app that tracks your activities every day, right? So you may have registered into this app a year ago or 2 years ago, right? So your journey with the app started at that time when you registered. So it starts relating and storing your activities as time goes by. So journeys are not very well defined in there. So there have been some time-based ways of splitting these long journeys into shorter ones so that you can analyze it. So for example, they figure out when the person sleeps. So let's say I am going to cut the long journeys into smaller ones when a person goes to sleep. That's pretty straightforward and easy. But there are other cases where the time-based activities don't work very well. The time-based cuts don't work very well. So we have been working on techniques of basically splitting very long activities the user performs on a particular service into smaller ones. We investigate further the relevance of its process mining activities for customer journeys, and we recently published a new demo. It actually happened at the end of last year. It's called Visual, which is an enhanced version of the CJMX. It was published in the International Conference on Process Mining and got the Best Demo Award. So I'm going to show you a little video of it as well. I cannot demo it again. Let me see how I will share this one. Okay, you should be seeing a little movie here. So this little tool, it's extremely simple. This is a portion of the tool. It's not the whole tool. Again, I'm going to give Yanis the URL where you can find information about all this. I believe Gael wants to patent this whole thing. So we published two components, the demo and the work behind it. So the work behind it is getting rid of all the clustering that we did, getting rid of all the hierarchical component that is very expensive and is based on a new sampling technique of very large event logs. So in this tool, in this tool, you will see, again, the little squares represent different activities. A horizontal set of squares is a trace, an event log. So this is the Chicago data set. It has the same things, and you will see how the sampling, in this particular video, the sampling works in real time. So what we're doing here is we will be selecting with the mouse a set of these rows, and in real time, it is going and it is performing the clustering and based on the sampling of activities with an extremely high quality. So you will see how he's drilling down from the 29,541 number of these rows into 2. So here it is. He's selecting, and this is what's underneath. You see the number is decreasing. He's selecting. This is happening in real time. This tool does not exist out there. So what people liked was the simplicity of the tool here. So this is happening real time on large data sets. We can even do it in millions or even more of such traces. So I will leave the link. Whoever wants to try it, it's also a Python, it's open source. You can download it and you can play with it. It was a requirement of the conference, so we have to make it available. So this is the end of this presentation. I'm sorry if I went a little bit fast sometimes, but I'm here to answer any of your questions. Thanks for your attention.
Σε ευχαριστούμε πολύ, Περικλή. Πολύ εντυπωσιακή δουλειά και μάλιστα καλύπτει και ένα κενό, γιατί για process mining δεν έχουμε μιλήσει στο μεταπτυχιακό στο μάθημα, οπότε τα παιδιά πήραν και μια ιδέα από αυτή την περιοχή. Ερωτήσεις.
Δίνεις traces of events και σου βγάζει ένα process model. Αυτή είναι η γενική ιδέα.
Ναι.
Ερωτήσεις.
Να κάνω εγώ μια ερώτηση και μετά ρωτάμε πάλι και το ακροατήριο. Πριν δείξεις αυτό το demo, το τελευταίο, ήμουν έτοιμος να ρωτήσω, αντί να κάνεις clustering, γιατί λίγο πριν είχες πει ότι θα κάνω clustering όταν έχω πολύ μεγάλο όγκο από traces, να έκανες sampling.
Ναι.
Θα ρωτούσα. Μετά όμως είδα το βίντεο, κάνεις sampling, αλλά το κάνεις με εποπτικό τρόπο. Δηλαδή ο χρήστης διαλέγει κάποια που του φαίνονται ότι πρέπει οπωσδήποτε να είναι στο δείγμα.
Ναι.
Όταν έχεις πάρα πολλά όμως, ίσως ο εποπτικός τρόπος να μην είναι και ο βέλτιστος, να πρέπει να ακολουθήσεις μια κλασική από τη στατιστική διαδικασία sampling. Αυτό το έχετε δουλέψει καθόλου?
Το δουλεύουμε as we speak αυτή τη στιγμή. Έχουμε κάνει πειράματα. Το δουλεύουμε as we speak. Στην κοινότητα του process mining, ο εποπτικός τρόπος είναι αυτός που περνάει περισσότερο από τους υπόλοιπους. Καταλαβαίνω το κομμάτι του data management, large data, διαφορετικά sampling, να διαλέγεις τα καλύτερα κομμάτια από... as we speak, αυτή τη στιγμή, κάνουμε πειράματα σε αυτό το κομμάτι.
Ωραία. Άρα δεν έπεσα πολύ έξω.
Δεν έχω απλά να πω κάποιο αποτέλεσμα.
Ναι. Αλλά είχε λογική αυτό που ρώτησα.
Ναι.
Ωραία. Έχουμε κάποια άλλη ερώτηση? Δεν ακούω κάτι. Δεν βλέπω χέρια να σηκώνονται. Οπότε, οκ. Ας το κλείσουμε εδώ. Να σε ευχαριστήσουμε και πάλι, Περικλή, πάρα πολύ που ήσουν μαζί μας σήμερα και να ευχηθούμε ακόμα περισσότερες επιτυχίες στα επόμενα βήματα ερευνητικά που κάνεις με την ομάδα σου.
Ευχαριστώ πολύ. Όπως είπα, θα σου στείλω και PDF από τα slides και τα διάφορα links. Οπότε, αν θέλει οποιοδήποτε, μπορεί να κοιτάξει και τη δουλειά και βασικά πολλά από αυτά έχουν βιντεάκια. Γιατί στο Process Mining Community χρειάζεται να κάνει submit και βίντεο με τη δουλειά, το οποίο μας έχει βοηθήσει εν μέρει στο να παρουσιάζουμε τη δουλειά μας.
Βέβαια.
Είμαι που δεν μπορούσα να πω στα 2 demo, αλλά θα δείτε τα βίντεο και μπορείτε να κατεβάσετε τον κώδικα από το τελευταίο και να παίξετε μαζί του. Ευχαριστώ πάρα πολύ. Ήταν μεγάλη τιμή μου να μιλήσω στο group.
Και για μας. Να είσαι καλά, σε ευχαριστούμε πολύ. Καλό βράδυ σε όλους.
Καλό βράδυ.